The quality control director of a small company that manufactures exercise equipment knows that 10% of their products are defective. Market research shows that only 30% of their customers will use the product within the first year after the sale. So the manufacturer expects that 3% of the units will be returned for service under a 4-year warranty. Under a 1-year full warranty. The company expects to sell 600 units next year. Describe the sampling distribution of P hat, the proportion of the 600 units that will be returned for service. Right, so a lot of percents going on here, but we have to focus on what we're talking about. So we're focused on the percent or the proportion that will be returned, right, to the returned for service here. So 3% is what we're looking at. So that's our P. Right. So go through our conditions here. So we want to look at N times P times 1 minus P. So 600 times 3% times 1 minus 3%. And we want that to be greater than or equal to 10. And we get 17.46. So we're good to go there. And we want to check either n is lowercase n is less than or equal to 0.05 capital N, or our sample values are independent. So we can safely assume here that our sampled values are independent. We can actually check that, right? So actually, let's go back and look at this. So assume that our sample values are independent, right? So let's do a little review here real quick, instead of assuming this. Right? So if they're going to be returned for service, that means that they have to be defective and they've used them in the first year, right? So if we look at that, right, so the probability that they're get a warranty is that they're defective and they use them. Right, so if we think about that, they're telling us that there's 3% of them. Then we look at this, defective, and use that they're independent, right? We just multiply them together. So the defective ones are 10%, and the used ones are 30%. So if we multiply those together, 10% times 30%, we get our 3%, so they are independent. So our sampled values are independent. All right. So then we just need to find the mean and the standard deviation. So our mean here is E, which is 0.03, and our standard deviation is going to be the square root of P times 1 minus P divided by lowercase n, so 0.03 times 1 minus 0.03 divided by 600 here. .03 times 1 minus 0.03 This is 0.0291 divided by 600, and then we take the square root of that, divide that by 600, and we get a scientific notation again, so I'm going to leave that in this form, and then we're going to do second x squared to get the square root, and second negative to call upon our answer, close my parenthesis and enter. So this is approximately 0.00696 is our standard deviation. So let's slide this down here. So we get here that our the sampling distribution of p hat is approximately normal, since times p times 1 minus p is greater than or equal to 10, and the sampled values are independent, with mean 0.03 and standard deviation 0.006964. So we have our description of our sampling distribution. So now we want to know what's the probability that more than 3% of the 600 units will be returned for service. So we're in our statement here, so we're looking for the probability that p hat is greater than 0.03. So what do you notice here? What is this 0.03 or the 3%? That's the mean, right? So we should know that this is equal to 50%, 4.5, right? So now we want to know what's the probability that more than 5% of the 600 units will be returned for service. So we're looking at more than 5%. So we're looking for the probability that p hat is greater than 0.05. Right? So divide this up. Our mean is going to be 0.03. Our standard deviation here is going to be the square root of 0.0291 divided by 600. And then our StatCrunch statement is the probability that x is greater than or equal to 0.05. Right, so that's what we're looking for here. So we're going to type in our mean and our standard deviation here. So SQRT for square root, open parenthesis, 0.0291 divided by 600, close parenthesis, come down here, greater than or equal to, so we're going to pick that from the drop down menu, and then we're going to change our value here to 0.05 so that we have the probability that x is greater than or equal to 0.05, and we're going to hit compute. So our probability here is 0.0020. Right. And our last question here asks, would it be unusual if in a random sample of 600 units, more than 5% would be returned for service? Right, so yes, right, it would be unusual since our probability here is less than 5%.